morning to Dr. Fadila and my fellow friends. My name is Fendi bin Mita, and today I will be presenting for the subject wastewater management. So, my presentation is a real world case study on designing a custom wastewater treatment plant for industrial wastewater with a specific focus, which is the textile industry. So this presentation will discuss the nature of the textile wastewater, the challenge involved, the proposed treatment design, and also its cost and feasibility. Okay, next. Okay, this is the background and the significance of textile wastewater in Malaysia. So the industrial wastewater management is a growing environmental concern with the textile industry then identified as one of the most water intensive and pollution generating sectors globally and also in Malaysia. So the textile effluent contain the synthetic dye, heavy metal, high COD and BOD, and suspended solids that pose serious risk to aquatic ecosystem and also human health. So in Malaysia, the textile wastewater contribute about 22% of total industrial effluent and frequently exceeding the discharge limit set under the environmental quality or industrial effluent regulation 2009. So poorly treated textile discharge will cause the reduced light penetration, deplete dissolved oxygen, disrupt photosynthesis, and contribute for long-term surface water and groundwater contamination. Okay, next. So uh, back again, limitation. So this is the limitation of conventional treatment and emerging solution. So conventional treatment methods such as coagulation, oxidation, and activated sludge system face challenge including high operational costs, incomplete decolorization, toxic byproduct formation, and also sludge disposal issue. So adsorption has gained attention as an efficient and cost-effective alternative due to its high pollutant removal efficiency and operational simplicity. This is according to Hassanov 2022. So activated dolomite has demonstrated excellent performance in textile wastewater treatment, achieving high color, COD, and microbial removal while using abundant and low-cost natural material. And also recent studies show that integrating dolomite adsorption with biological and electrokinetic processes enhance treatment efficiency and support sustainable and regulatory compliant wastewater management. Okay, next. So now let's take a look about the case study overview and wastewater characteristic. Okay, so this is overview of the selected case study and the general characteristic of textile wastewater. So if we take a look at this slide, we can see that the textile wastewater is typically characterized by high color intensity and high pollutant concentration, so making the treatment very challenging. Okay, it also have a presence of Escherichia coli, which indicated the microbial contamination posing potential environmental and public health risk if untreated. Okay, the others you can see in this slide. Okay, next. Okay, now moving on to the treatment performance and design implication. So if we go through at this slide, we can see that the treatment performance observed in the case study provide important information for designing and also effective treatment system. So these are the findings that will influence the selection of treatment process and also help to ensure that the final effluent meet discharge requirement. Okay, next. Okay, this is the problem analysis of textile wastewater. So this slide focus on the what are the problem analysis, and you can see that textile effluent it contain pollution that are resistant to degradation and difficult to remove using standard treatment. Okay, if this wastewater is discharged without inadequate treatment, it lead to serious environmental consequences. Let's take a look. First one is high persistent dye concentration causes severe water colorization. Second is elevated COD reflect excessive organic pollution load. Third is microbial contamination will increase the public and environmental health risk. So the last one is heavy metal accumulate and then threaten aquatic ecosystem. So these are the problem that we found. Okay, next. So what are the environmental consequences? So let's take a look at the environmental consequences of textile wastewater. So the intense coloration of the textile wastewater can cause reduced sunlight and aquatic photosynthesis, and also um, it also can cause oxygen depletion that will next lead to eutrophication and aquatic life loss. Third is persistent dyes and metal will contaminate the groundwater and sediment. The last one is anaerobic decomposition will produce odors and degrade the soil quality. Okay, next. Okay, this is the technical challenge in textile wastewater treatment. So conventional treatment that usually been used show incomplete dye and color removal. Also, the chemical and oxidation methods will generate sludge and byproduct. The third one is biological processes ineffective against complex synthetic dyes. And the fourth one is adsorption is effective, but it is constrained by energy and also operating costs. Okay, next. Okay, what about the regulate, regulatory and compliance challenge in Malaysia? So the strict effluent standards, this have given challenge to textile industry compliance according to DOE Malaysia 2009. So it will cause high costs and also outdated system will hinder the regulatory adherence according to Zahuri 2023. And also non-compliant raise penalties and global market exclusion. And the fourth one, SMES, require scalable low-cost treatment uh, solution. Okay, this is the regulatory and compliance challenge. Okay, next, let's take a look at the socio-economic and sustainability consideration. So the textile effluent pollution, this threaten public health and livelihood. Also, the rising public pressure demand for environmentally responsible industries practice. So local adsorbents reduce cost and support sustainable treatment system. And also integrated treatment approach will help to improve efficiency and also economic viability. Okay, next. Okay, this is the treatment plan design and justification. For the pre-treatment and flow stabilization, we have a screening that will help to remove fibers and debris and preventing clogging and mechanical damage. We also have a great removal project pumps, a mixer and pipeline from abrasion. So equalization tank, this help to stabilize flow, pH and also pollutant fluctuation. Uh, the coagulation and flocculation help to reduce turbidity and protect adsorption efficiency. For the main treatment and policing processes, we have primary clarification that help to remove flocks and also suspended solids before it advance to treatment. Also activated dolomite adsorption achieve high color and COD removal. Sand filtration and disinfection, this will help to ensure safe discharge meeting standard air limits. The sludge dewatering uh, will help minimize waste volume and ensure compliant disposal. Okay, next. So this is cost and feasible analysis. So the total capital investment remains feasible for small medium textile industry. And a major cause it is arise from adsorption, sludge handling, and also civil structure. Local material and simple processes will help to reduce long-term operational expenses. Also, design supports regulatory compliance with a manageable capital and maintenance costs. Okay, next. So this is the estimated annual operating cost. So the operating cost it remain moderate for small medium textile industries, and also energy absorbent replacement and labor uh, form a major expenses. So uh, and also the local materials and simple operation will help to reduce long-term financial burden. And compliance benefit outweigh costs through reduced environmental and legal risks. Next. So if we take a look at this aspect and also the evaluation, we can take a look at the cost effective and feasibility assessment. So moderate capital investment is suitable for small medium textile enterprise. So activated dolomite help to lower operating costs versus uh, if is if it is imported for treatment materials from outside, so it is more lower lah. So the third one is simple unit operations, reduce energy demand and technical complexity. The last one is the modular design, ensure long-term compliance and sustainable expansion. Next. So this is the conclusion. So in conclusion, the textile wastewater uh, it presents significant environmental and operational challenge. So the proposed treatment plan design hopefully will provide an effective and feasible solution using a structured treatment approach. So by integrating the activated dolomite adsorption with conventional treatment process, the system achieved regulatory compliance while remaining economically and environmentally sustainable. So that's all from me. Thank you.